morning, students. I am N.V. Krishna Rao, Assistant Professor, CSC Department. I am handling the compiler design. So today we will discuss the definition terminology of the second unit, syntax analysis. And we discuss the definition terminology of the second unit, syntax analysis. The first one is parser. What is a parser? Parser takes input in the form of sequence of tokens and produces output in the form of parse trees. Right? A parse tree takes input. A parse tree takes input in the form of sequence of tokens and produces output in the form of parse tree. The second phase of a compiler is syntax analyzer. Right? Source program as input to the lexical analyzer. That is the first phase of the compiler. Right? That is the first phase of the compiler, which generate a token, which is the input to the syntax analyzer. Lexical analyzer, which gives a token. The token is a input to the syntax analyzer or parser. Here, this lexical analyzer gives tokens. The tokens are given to syntax analyzer. The syntax analyzer, the parser, will construct syntax trees from these tokens. Meanwhile, it will request another remaining tokens, and so the lexical analyzer will work in parallel to the syntax analyzer to construct the tokens. So, lexical analyzer first generate some sequence of tokens that given to the syntax analyzer. Then the syntax analyzer requests another set of tokens that to lexical analyzer, so that the lexical analyzer will prepare some other tokens and will be sent to syntax analyzer. So in this way, the communication will be done between lexical analyzer and syntax analyzer. So the communication between the lexical analyzer and syntax analyzer is done. Here, the both phases are connected with a symbol table, where lexical analyzer will store the information about the variables and syntax analyzer will update some information, and it is used and accessed from the data from the symbol table. Right? So, syntax analyzer will take the sequence of tokens and gives the output a parse trees. Right? So, role of a parser is a syntax analyzer are called as parsing or syntax analysis. The parser obtains a string of tokens from the lexical analyzer and verifies that the structure generated by tokens based on the grammar of the source program. It builds the parse trees. And reports the errors. Error recovery from commonly occurring errors so that it can continue processing its input. So error recovery from commonly occurring errors so that it can continue processing its input. So that is the parser as syntax analyzer, which takes a sequence of tokens as an input and generates the parse trees. Then list the types of parsers. There are two types of parsers. top-down passing method, bottom-up passing method. There are two types of top-down passing methods, bottom-up passing methods in constructing the passes. Here, when you consider the top-down passing method, there is a main one is LL passing method, predictive passing method. These will depend on the top-down passing method, right? Bottom-up passing method will consider as main one are SLR, CLR, LALR passing method. So the LR passing methods are very important in bottom-up passing methodology, and LL passing, predictive passing, LL passing methods are important in the top-down passing methodology. So top-down passing method means we construct a tree from the root to leaves. Bottom-up passing method, first we consider the leaves, then we group them to construct the root, right? So top down is from the root to terminals, the leaves of the tree, right? Then we consider root, and we apply the direction of some productions. We derive from applying the derivation of some productions, and finally we construct the leaves. Then finally we construct the leaves. Another one, bottom up passing method. In this bottom up passing method, the leaves are considered, the terminal symbols are considered, will match with the right side of the productions so that it is replaced by non-terminals, right? Bottom up passing method, where the terminals or the leaves are considered, the terminals or leaves are replaced with the root or non-terminals, right? Then we check once again, these non-terminal and terminal is matching with any right side of the productions, so replaced with the left side symbol, so that from the leaves or the terminal symbols we construct the root, right? So that is a bottom up passing method. So what is passing? In the bottom up passing starts with the symbols, input symbols, and construct the pass tree up to the start symbol by tracing out rightmost derivation of the string in reverse. Top down passing we uses leftmost derivation. Bottom up passing we uses rightmost derivation, which is in reverse. First we find the matching of the symbols of the right side. It is replaced with the left side non-terminal of the production. So here the construction of pass tree from the non-terminals to start symbol by tracing out the rightmost derivation in reverse. Then top down passing method. Top down passing method construct the pass tree from the input string starting from the root node and creating the nodes of the pass tree. It starts from root node and creating the nodes of the pass tree in pre-order. It is done by leftmost derivation for the input string. So in the top down passing method, we start constructing the tree from the root and we consider the leftmost derivation so that we'll match the non-terminal with the productions and we'll apply the right side of the production so that we construct the leaves or the non-terminals of the tree, right? So here we uses the leftmost derivation for the input string, whereas bottom up passing method we use rightmost derivation, right? What are the tasks performed by the parser? The first one It will detect all types of syntax errors. It helps you to detect all types of syntax errors. Right? The main task of the syntax analyzer is to find syntax errors. What are the syntax errors? For example, in a programming language, every statement should end with semicolon. It must end with some semicolon. It will check each statement is ending with semicolon or not. A binary operator should have two operands. It will check the operator is associated with the two operands. Right? So, the first task of the parser is to detect all types of syntax errors. Then, find the position at which error is occurred. Clear and accurate description of the error. Second task, find the correct location of the error in a statement and write about description of the error so that programmer can easily understand the error. Recovery from an error to continue and find further errors in the code. So here, this in the parser also associate with the error handler for some general regular errors will be recovered by itself so that the compilation process will be continued. The parser must reject invalid text by reporting the syntax errors. So these are the main tasks of the parser, right? To detect all the syntax errors and find the correct position of the errors, clear and accurate description of the errors, recovery from an error to continue and find further errors in the code. The parser must reject invalid text by reporting the syntax tree. Okay? Then, common errors that occur in parsing. Right? What are the common errors occur in the parser? Right? Here, the common errors, the lexical says name of the incorrectly typed identifier. Lexical analyzer will concentrate on the name of the incorrectly typed identifier. Syntactical. The syntactical says that unbalanced parentheses are missing semicolons. Syntactical says that unbalanced parentheses are missing semicolon. Next comes to the semantical. The semantical says that incompatible value assignment. The semantical says that incompatible value assignment means that the parse trees are executed correctly or not. Syntactical says the statement ending with semicolon is correct. Binary operator is with two operands is correct. It is any block is started correctly with the flower bracket and closed with the flower brackets. And if you are using the parentheses, they are matching with the parentheses. They are balanced or not. All these syntax structures are verified by the syntactical. Semantical is an incompatible value assignment. So here semantical says that the parse tree will execute properly or not. The parse tree will execute properly or not. Then logical, infinite loop and are not reachable code. Any such errors also it will be removed by the parsers. Next comes to the handle. Define handle. What is a handle pruning? These are the main used in the bottom up passing technology. Right? These are used in the bottom up passing method. A handle of a string. A handle of a string is a substring that matches the right side of a production and and whose direction to the non-terminal on the left side of the production represent one step along the reverse of the rightmost derivation. A handle of a string is a substring that matches the right side of the production and whose direction to the non-terminal on the right side of the production represent one step along the reverse of the rightmost derivation. That is called as handle. Means that the substring that is matching with the right side of the production, so that the substring can be replaced with the left side non-terminal. This is a step in the reverse of rightmost derivation. Then, what is a handle pruning? If A gives beta, is a production that producing beta to A by a given production is called handle pruning. Removing the children of A from the path tree. The rightmost derivation in reverse can be obtained by handle pruning. So, selecting the substring is a handle by replacing with non-terminal, and the process is continued till the root, the reverse of the rightmost derivation, is called handle pruning. Right? If A gives beta is a production, then reducing beta to is a given production is called handle pruning. That is, remove of the children A from the path tree, and the rightmost derivation in reverse can be obtained by handle pruning. Right? So the process of replacing the right side of the production with the left side non-terminal and repeat till it finds the root is called handle pruning. Define shift reduce passing. Shift reduce passing is a bottom up passing method that reduces a string W to the start symbol of a grammar. It scans and passes the input text in one of the forward pass without backtracking. Here, it will perform three main operations: shift operation, reduce operation, then accept or not accept. Right? So, this is the one of the bottom up passing method that is called shift reduce passing method. So, handle is a substring that matches the right side of the production of a rule. But not every substring matches the right side of a production rule is handle. Right? Then, a handle of the right sentential form gamma, which is equivalent to alpha beta W, is a production A gives beta and a position of gamma, where the string beta might be found and replaced by A to produce the previous right sentential form in the rightmost derivation of gamma. So, S match derives alpha A W, which derives alpha beta W. Right? So, if the grammar is unambiguous, then every right sentential form of the grammar has exactly one handle. Right? If the grammar is unambiguous, there is only one handle. So, we will see that W is a string of a terminals. Here, the rightmost derivation in reverse can be obtained by handle pruning. Right? So, here W, gamma n minus 1, gamma n minus 2, gamma 2, gamma 1, finally it gives a string. Start from gamma n, find the handle. Find handle an gives beta n in gamma n. Replace beta n with an to get gamma minus n minus 1. And then replace to get gamma n minus 2. And finally, it will reach as. So, the process of finding the handle and performing the replaces with the non-terminal, and it is repeated till it reach the start symbol. The complete process we say as handle pruning. Finding the substring in the right side productions is a handle. Finding is handle substring properly. And performing this process some number of times to reach to the start symbol is handle pruning. It is called as a handle pruning. So here, the shift reduce process will have mainly 4 actions. It performs shift, reduce, accept, error are not accepted. So these are the main 4 operations, right? Possible actions in the shift reduce parsing method. What are the conflicts occurs in the shift reduce parser? There are 2 conflicts occur in shift reduce parser. Shift and reduce conflict. Reduce conflict. For some production, for input symbol, and for the stack symbol, they may result 2 actions, shift action, reduce action. Then we may have which one has to select is a headache. For input symbol and the stack symbol, they may result reduction of 2 productions. Then selecting the which production reduction has to take is a headache. So that is a problem with this one, right? Shift reduce conflict, reduce conflict. So what is shift step? The input pointer advances to the next input symbol by the shift step, and the next input symbol is known as shifted symbol, and the symbol is pushed upon to the stack. The shifted symbol is considered as a single node of the parse tree, right? So what is the shift step? The input pointer advances to the next input symbol by the shift step, and the next input symbol is known as shifted symbol, and the symbol is pushed upon to stack. The shifted symbol is considered as a single node of parse tree, right? So here there are 4 possible actions in the shift reduce process. The first one is shift. The next input symbol is shifted onto the top of the stack. Another one is reduce. Replace the handle on the top of the stack by the non-terminal. Replace the handle on the top of the stack by the non-terminal, right? Reduce means replace the handle on the top of the stack with the non-terminal. Then accept. Successful completion of the parsing. Then another one is other. Parser discovers a syntax error and calls an error recovery routine. Parser discovers a syntax error and calls the error recovery routine. Initially, stack just contains only the end mark $, and end of the input string is marked by the end marker $sign. This is an example for stack implementation of the shift reduce parser. So initially $sign it completed with the input string. So we are just performing shift action. So what happening? This ID is moved to stack. That ID moved to the stack. Then check this ID is matching with any right side of the production. Means find the handle. Replace this ID with non-terminal F. Then check this handle might be matching with any right side of the production with T. Then T as E. So we are reducing these handles with respect to non-terminals. Then perform the shift action. Then perform the shift action operation. Then perform ID as F, F as T. Then move this multiplication E plus T into. Then perform this ID. Right? Then ID as F. Then find this terminal T into F as simply T. E plus T into F as T. Then E plus T as E. Then E plus T as E. Right? Finally, the given input string is emptied and stack results with root. Stack results with root. Simply we say it is accepted. Simply we say it is accepted. So reduce step means right hand, when a complete grammar rules right hand side is replaced by left hand side, it is termed as reduce step. The stack performs a pop function which facilitates in popping off the handle and replacing with the left hand side non-terminal symbol. So this is called as a reduce step. Then LR parser. What is LR parser? The LR parser is a non-recursive shift reduce bottom-up parsing method. It uses wide class of context-free grammars which makes it the most efficient syntax analysis technique. So the most of the parsers are generated by the LR parsers. Here these are the non-recursive shift reduce bottom-up parsing method. So it will accept more, it will be constructed for more number of context free grammars. So what is LRK parser? LR parsers also known as LRK parsers, where L stands for left to right scanning, L stands for left to right scanning of the input string, R stands for instruction of the rightmost derivation in reverse. R stands for construction of the rightmost derivation in reverse. And K denotes number of lookup symbols. K denotes the number of lookup symbols to make the decisions. So it might be LR0 or LR1. LR0 says that 0 lookup symbols. LR1 says that 1 lookup symbol. To make the decisions means to perform shift operation or to perform reduction. To decide these operation actions, it considered the lookup symbols. Right? The list the different types of LR parsers. Here the LR parsers are divided into 4 parts. LR0 parsing method, simple LR passing method, canonical LR passing method, look ahead LR passing methods. So these are the four different LR passing methods. So what is LR algorithm? LR algorithm requires a stack, input, output and passing table. Here LR passing, it takes the input and pushes the symbols to the stack, and it refers to the stack symbols and also the input symbols passing table. Depending on the passing table specified which action is to take, that will be followed, right? So what is the input buffer? Input buffer is used to indicate the end of the input, and it contains a string to be passed followed by dollar symbol, right? So the input buffer will consider the input string to be passed and it will end with dollar sign. So what is passing table? The passing table has two parts. The passing table is two parts. One is action part, another one is go to part. The action part of the passing table, which contains the column headers as non-terminals. The column headers are non-terminals. Whereas the go to part, the column headers are non-terminals. Action part will consider column headers are the terminal symbols, right? Action part will consider a terminal symbols. Go to part will consist non-terminals as the column headers, and it is the two parts of the passing table, right? This passing table will have the states and the terminal symbols in the action part, non-terminal symbols in the go to part will filled with the shift action, reduce action, others or accept. The four actions are filled in the passing table under the terminal columns, that is action part, non-terminal columns, that is go to part. What is augmented grammar? Augmented grammar G dash will be generated if add one more prediction in the given grammar G. It helps the parser to identify when to stop the parsing and announce the acceptance of the input. For example, this is a given grammar and this is the additional added production. So it will say when to stop and passing, when stop the passing and announce the acceptance of the input. What is SLR1 parser? What is SLR1 parsers? It is a simple SLR parser. It is a simple LR parser. It is simple LR parser. It works on smallest class of grammar. It works on smallest class of grammar. Few number of states, hence very small table. Right? Simple and fast construction. Right? So SLR is a simple LR parser. It works on smallest class of grammars. Few number of states, hence very small table. It will have passing table. And it is simple and fast construction. So the most powerful shift reduce passing method is LR passing method. It is left to right scanning. The L meaning is left to right scanning. R means rightmost derivation in reverse. Right? K means number of locate symbols. LR passing is attractive because it most non-backtracking shift reduce passing method. It is efficient method. Non-backtrack shift reduce passing method. Here, backtracking means when you select a position for the derivation, it will not resulting properly. Then go back and select alternative predictions. That selecting, applying, and go back and replace the production with another alternative production, that backtracking is avoided in this LR passing methods. So this LR passing is most general non-backtracking shift reduce passing. The class of grammars that can be parsed using LR methods is a proper superset of a class of grammars that can be parsed with predictive passes. Right? The predictive passes LL1 grammars are a subset of LR grammars. So these LR grammars will accept more. We can be construct a for the more number of context field grammars than LL1. So, an LR passes can detect syntax errors as soon as it is possible to do a left to right scan of the input. So, SLR passes, canonical passes, lookat passes, these are the main three categories of the LR passes. All these three work same, but the only is the different, the passing table. The construction of the passing table is only the difference, but the procedure is the same. Right? So, the action table, the terminals and $sign will be the column headers in the action part of the passing table. So, the passing table has two parts, action table and go to table. Right? Action table and go to table. Action table will consist column headers, the terminals and $signs. Go to table consists the column headers as non-terminals. Right? So here the stack contains a state followed by symbols. Right? Input will consist the input symbol and end with $sign. So that the input buffer will consist the input string end with a $sign. So here this is the LR passing algorithm and it gives the output. What is a LR1 parser? LR1 parser also LR parser only, but it works on complete set of LR1 grammars. It generates large table and large number of states and slow in construction. And it considered one symbol a lookat symbol. One indicate one lookat symbol. Right? It is a LR parser. It works on complete set of LR1 grammar. It generates large table and large number of states and slow construction. So what is LALR parser? It look ahead LR parsers. Their LALR says as lookat LR parsers. It works on intermediate size of the grammar. The number of states are the same as in SLR. So what is the difference between LL and LR parsers? LL parser means leftmost derivation is done. Parse tree built using the top-down parsing methodology. It starts with the non-terminal on the stack. Root non-terminal. It starts with the root non-terminal on the stack. Here LR passes, it uses the rightmost derivation, it uses the bottom up passing method, it end with root non-terminal. It starts with root non-terminal, it ends with root non-terminal on the stack. So the resultant final symbol in the stack is a root non-terminal. CLI1. CLI refers to canonical lookhead. CLI passing use canonical collection of LR1 items to build the CLI passing table. This CLI passing table produces more number of states as compared to the SLI passing method. This CLI will produce more number of states as compared to the SLR passing method. What is LR? LR item is collection of LR0. LR1 item is a collection of LR0 items and a lookup symbols. LR1 is item equal to LR0 item plus lookahead. It will consider one lookahead symbol. The lookahead symbol used to determine that where we have to place the final item. The lookahead always add dollar symbol as the argument protection. Then what is YAC tool? YAC is represent at another compiler. At another compiler. It provides a tool to produce a parser. It produces a parser for the given grammar. This YACC is a automated tool which takes the grammar and produces the parser. Is a program designed to compile LLR grammars. Right? This is a automated tool, right, which takes the input as a grammar and generate the parser. That parser will take sequence of the tokens and generate the parse trees. Right? This is an automated tool to generate the required parser for the given grammar. So here the basic structure of these consists definition, rules and subroutines. Definition, rules and subroutines. These three sections are separated by a separators as colons. So declaration section, translation rules and supporting C function. The parts of the at another compiler specification. What is panic mode as a recovery? What is phrase level as a recovery? So these are the two types. Panic mode as a recovery, phase level as a recovery. In the case when parser encounters an error, this mode ignores the rest of the statement and not process the input from the erroneous input to delimiter like semicolon. This is a simple recovery method. It says remove the next symbols till the semicolon or till the white spaces, till the blank spaces. That is a panic mode as a recovery. Right? In this case, the parser encounters an error. This mode ignores the rest of the statement and not the process input from erroneous input to the till the delimiters. Then, what is a phrase level as a recovery? Compiler corrects the program by inserting or deleting the tokens. This allows it to proceed to pass from where it was. It performs correction on the remaining input. It can replace a prefix of the remaining input string with some string that helps parser to continue the process. The panic mode neglect the input till the next delimiter. Phrase level, as Zikawa says, it can add some tokens, or delete some token, or modify the some token such that the passing will be continued. Such that the passing will be continued. That is a phrase level as a Zikawali. Then canonical collection of LR0 items. LR0 item is a production of G with dot at some position on the right side of the production. LR0 items is useful to indicate that how much of the input has been scanned up to given point in the process of processing. So here the productions will have a dot indication saying that how to which symbols the input is passed, right? So this one are the terms definition terminology for the second unit, syntax analysis. I'm closing this section. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.